In this video, you're going to start learning about one of the final features of asynchronous programming in JavaScript that I want to cover in this section. That is AsyncAwait. AsyncAwait is the combination of two new JavaScript tools. We have the async function and the await operator. When we use them together, we get a new way to structure and work with our promises that makes code a whole lot easier to work with. Now we're going to explore this, as always, first in isolation, then we'll integrate it into the Hangman application. So over in the functions directory, let's create a brand new file. I'm going to call this one async-await.js, and the good news is that understanding this feature is going to be relatively simple because it really just builds off of what we already know about promises. So all of the work we put into learning promises in the last 6 videos is going to make understanding async-await pretty easy. And we're going to kick things off with a basic example. Let's go ahead and kick things off by creating a basic function. I'm going to create a const right here, and I'm going to call this one something generic like process data. And all we're going to do is set up a regular old boring arrow function. We're not going to set up any arguments. We're not going to set up anything in the function body. This is intentional for the moment. Eventually, we'll fill out process data with some code. Now down below, what I'd like to do is actually call process data and print its return value. So I'm going to call console.log. In here, as the first argument, we will provide whatever comes back from calling process data with no arguments since it expects none. Now, based off of what we learned about functions in one of the first sections of this course, we know that undefined is going to print. Undefined is the default return value if you don't explicitly return anything. We can actually prove that by rerunning the script from the terminal. I shouldn't have said rerunning since we're running it for the first time. That is node async-await.js from the functions folder. When I execute the script, we get undefined. Now what I want to do is start introducing async-await. And we're going to do this by adding a single word into the code and viewing how that changes the output. This is the async keyword. When we create a function, we can choose to create a function as an async function. To do that, all we do is right before the function definition, we use async just like this. Now we've successfully created an async function, that is the async portion of AsyncAwait. We'll explore exactly what this allows us to do in a second, but what I'd like to do is just save the program and rerun it, only having added that keyword in. Over in the terminal, I am going to rerun the script, and what am I getting this time around? I'm actually getting a promise. And that brings us to the first important feature of the async function. Your async functions always return a promise. That promise is resolved with the value that you, the developer, choose to return from the function. So let's go ahead and clarify that. Let's say that I, the developer, choose to return 12 from this function. What comes back from process data is not 12. It would if we were to remove the async keyword. In this case, we would see 12 printing. When we add on async, we always get a promise back. The promise gets resolved with whatever value we return. So that means we can structure our code a bit differently down below. I'm going to go ahead and call process data. And we know that a promise comes back. We just proved that via the value we saw in the terminal. So what am I going to do right here? I'm going to attach then. .then for this promise. We're going to set up our success handler for when the promise resolves a value. And in this case, we're just going to get the data and we're going to print it. Console.log. And I'm actually going to pass 2 arguments in. The first being the string data and the second argument being the actual data variable. When we pass multiple arguments into console.log, console.log just logs them all in order. So the end result of this is just going to be us seeing our data. I'm going to save AsyncAwait. We're going to rerun the script from the terminal, and what do we get? We get data 12 showing up. So we know that async functions return a promise, and we also know that the value we return from the async function is the value that the promise gets resolved with. Now we can also have a catch handler for our async function. Right here, I can attach catch. I'm going to set it up with a little arrow function. We'll get access to the error argument, and we're just going to print it like we did up above. The first argument, the string error, and the second one, the actual error itself. this catch handler is going to run if the promise that comes back from the async function rejects. This promise is going to reject if we, the developer, choose to throw an error from the function. So throw new error, and then right here, a string something went wrong. So this code, the code that throws the error, is going to cause the promise that gets returned from our async function to reject, and that is going to cause the catch handler to run down below. If I save AsyncAwait and rerun the script, we should see the error, and that is exactly what we're getting. We're getting our error, something went wrong. We can see it's coming from process data on line 2, which does indeed line up with where we're throwing the error up above. Now at this point, yes, we might understand how async functions work. I see that when I throw an error, it's like rejecting, and I see that when I return a value, it's like resolving. But this doesn't seem particularly useful because we're not actually doing anything asynchronous. For the moment, let's go ahead and grab one of our dummy promise functions from promises.js. In here, we had created getDataPromise. This just took a number, it then returned a promise. We waited 2 seconds and we resolved the number times 2. We're going to use this to simulate how AsyncAwait works. I'm going to highlight all the code that makes up the function definition. Over inside of AsyncAwait, we can go ahead and paste that up top. And now what I'd like to do is delete everything from inside of process data and talk about the second half of AsyncAwait. We've already seen how we can use the async keyword to define an async function. We also have the await operator. It's important to note that the await operator can only be used with async functions. So that is why when people refer to this feature, they usually refer to it as one thing, AsyncAwait, as opposed to 2 separate features, the async function and the await operator. If you use one, you're most likely using the other. Now what I'd like to do is figure out how we can actually use await, and let's say the goal is to use getDataPromise a couple of times inside of process data. If we didn't use the async function, we know what that would look like. I'd call getDataPromise, I would pass in a number like 2, getting 4 back. I would then attach then to access the value. I would set up the success handler. Right here, I'd get the data, and then I could do something with the data, like console.log data. Not particularly interesting. We already know how to do that. Let's go ahead and see how we can get the exact same thing done using the await operator. So right here on the first line of the function, what we're going to do is call our function with the await operator up front. So await followed by getDataPromise, still passing in the arguments it expects, in this case 2. Now this syntax should look relatively familiar. We did something very similar when we created a new instance of one of our classes. We used the new operator with the constructor function that allowed us to create a new instance. In this case, we are using the await operator with a function that returns a promise. Now this is where things get cool. We don't have to attach then and set up a callback function. We don't have to do any of that. This looks like synchronous code, which means if we want the value that comes back from getDataPromise, we just store it in a variable up front. Const data equals, we await getDataPromise, passing in 2. Now on the next line, like it was normal, regular code, we can console.log data. So I'm going to go ahead and do just that. Right here, I will print data to the screen. Let's go ahead and actually test things out. I am going to save AsyncAwait. From the terminal, I am going to clear the program, and we can rerun our script. When I rerun it, we are going to have to wait those 2 seconds, but once we wait the 2 seconds, we do indeed see 4 printing. 4 is printing from the line right here, line 9 of AsyncAwait.js. And now we could actually expand on this further. Previously, if we wanted to use a promise multiple times, we had to use promise chaining. With AsyncAwait, we can just add a few more lines to the program, nothing complex. Right here, let's go ahead and switch data from a const to let so we can reassign its value. And on the very next line, I am going to set data equal to, I'm going to use await with getDataPromise again, and I'm going to pass in the current value of data. So we take 2 and double it to 4, we then pass in 4 and double it, and the end result should be 8. Now instead of printing 8 right here, we can actually go ahead and just return 8 by returning data, And we know that whatever we return is going to be the resolved value, so I would expect to see 8 printing when I print my console.log down below on line 17. I'm going to save AsyncAwait. From the terminal, we can rerun the program. We have to wait our 2 seconds, actually in this case 4, and once we do, what do we get? We get data 8 printing. So with async and the await operator, we can structure our code that uses promises to look more like regular old synchronous code. We can perform one operation after the other. This other code is never going to run until this promise either resolves or rejects. The return statement won't run until the second one either resolves or rejects. Now in this case, we've only seen the happy path where all of the promises do indeed resolve. Let's go ahead and explore what happens when one of them rejects. Right here, I'm going to remove the commented out code, and all I'm going to do is switch to be a string. I'll pass in the string ABC. So this should cause the condition over here to fail, which should cause reject to be fired. That means I would expect this to throw an error, and that's exactly what's going to happen. If I save AsyncAwait.js, over here, what do I get? I get, after about 2.5 seconds, number must be provided printing. So in this particular case, we can see that when one of our promises reject and we're using await with it, it's like we're throwing an error from this function. We're able to catch that error down below where we use the promise the function returns. This is exactly what we saw when we had manually typed throw new error previously in the video. In this case, though, we're not throwing the error on our own. Await throws the error for us if the promise is rejected. Now there we have it. We can see that promise chaining is no longer a daunting thing. I could easily add as many of these as I wanted on. I could just take this line, copy it down below, and now I'm chaining together 3 different promises, but in the end of the day, I don't have confusing promise code. I just have the async function with a few await operators. It's pretty easy to read through this file and figure out exactly how things work. In this case, if I were to save things and rerun them, after switching ABC over to a real value like 2, we would be able to see the final result print. That would be 16. If we do see 16 print, that means we're all done with our async await example in isolation. We are indeed seeing 16 print. And I want to figure out how we can make use of this technique in our actual code. We're going to go ahead and convert the code that gets the puzzle for us. Instead of working with fetch and attaching then to it, we're going to work with fetch and use it with the await operator, just like we've done here for our dummy function, getDataPromise. I'm going to take a quick moment to move AsyncAwait past the last of the Hangman files. I'm going to keep all of those up front, and we're going to make a change to requests.js. Now the nice thing about getPuzzle is that it already returns a promise. When we convert it to an async function, we know that by default it's going to return a promise, which means that we don't need to change anything in app.js. This code is going to stay exactly the same. AsyncAwait is going to help us over here where we actually have some more complex asynchronous looking code. Now, as always, we're going to take this function and duplicate it because I do want to compare and contrast the 2 examples after we go through the conversion process. Down below, I am going to paste another copy of getPuzzle. I'll call this one getPuzzleOld. And up above, we're going to kick things off by converting this function to an async function. Right up front of the function definition, async, then down below, we can actually take advantage of await. The first thing that we're going to await is the promise that comes back from fetch. When fetch resolves its promise, we know we get access to response. Instead of setting up then, though, we're just going to set up a constant response, and right here we are going to await our call to fetch. So we are going to await the fetching to complete. We'll store that in response, and then we'll continue on. Now we're going to fetch from the exact same URL. I don't want to type that out again, so I'm just going to copy the template string and paste it right inside of the fetch function. Now we can remove all of the other code down below, and we can continue on with what we want to do next. No need for then, no need for any sort of callback function. We just run one line of code, then we move on to the next line. Now the next thing we're going to do is look at the response status because that's important. We want to figure out if it was a 200. If it was, great. If it wasn't, that's fine too. We just want to run different code. Right here, if We're going to look at response.status, checking if it equals 200. This is the exact same thing we did down below. Response still has status, whether we use then or whether we use await. What comes back hasn't changed, it's just how we access it that's changed. Now for this if statement, we're also going to set up an else clause. And in the else clause, we're going to do the same thing we did before. We're going to throw a new error, and we're going to provide a message unable to get puzzle. Perfect. Now, what do we want to do in the success case? Well, previously, if things went well, we returned whatever comes back from JSON. This is a promise. So we get access to the promise data down below, which is the parsed JSON. With AsyncAwait, we can do all of that right here without any additional complexity. We can create a const called data, and I can set this equal to us awaiting, in this case, response.json. So the next line of the program isn't going to run until I have that parsed data. And now what's the real goal? The goal is to give us access to the puzzle right here. So if I want that as the value, I know I need to return that from the async function. So I am going to return data.puzzle. And that is it. This is how we can convert a function from using promises to using async and await. And now that we have our function in place, let's go ahead and save things and make sure the code still works. Over in the browser, we are still getting our puzzle. In this case, the puzzle is housewarming gift. That is coming from the fetch data from our async function. Now, if you were to show someone this function getPuzzle and this function getPuzzleOld and time them based off of how long it took them to figure out what's going on, I would bet that people are going to be able to figure out what's happening up above much quicker than what's happening down below. When we work with promises and then, it can be very clear what's happening if we have a simpler example like what we have over here. And this isn't going anywhere. We're still going to be using code like this throughout our programs. But when we have a bit more complexity with promises and we're trying to work with promise chaining, it's typically best to put that in an async function, allowing us to easily structure the code in a way that is more readable, easier to write, and more maintainable. So we're going to be favoring async functions when possible. Down below, we can actually go ahead and remove getPuzzleOld. No need for that anymore. And that's where we're going to stop for this one. In the next video, it is going to be up to you to convert some functions to async functions on your own. I'm excited to get to that challenge, so let's go ahead and jump right in.